Technologies, then he'd be wearing a real helmet.
Hi, my name is Cuevas, and I'm the project manager here at IDP Technologies. It's my job to introduce to you guys our capstone project, which is an impact distributing gel that we're going to be using to replace conventional foam padding within a sports helmet. Now, before we dive into the product, I think it'd be beneficial if I gave you an overview of the problem that we're addressing, which is concussions and any sort of blunt head trauma. Now, did you know that over the past 10 years, in young adults, children, and teenagers, the amount of concussions has increased exponentially to the point where there are registered 3 million concussions in the world. So I don't know about you, but I think that's a clear indicator that current technologies are not working correctly. So how about you guys follow me? We can look at our new product that we're creating as well as our competitors' products so you can see the differences in them. Alright, so as you can see here, we've got a plain on-the-market helmet. On the inside, the padding is made of polyurethane foam, pretty standard. Here is just a bare prototype of our product. It's a gel padding that we're going to be using and replacing the polyurethane on the inside. The problem with on-the-market helmets is that they only dissipate about 33% of the energy upon impact. And the goal of our product is that the padding and the helmet combined will dissipate 66%. Thus, less energy will reach the head, protecting it better. I just want you guys to keep in mind the basic physics about each padding. The polyurethane foam, it compresses upon impact, thus dissipating energy. The difference in our product is that the gel will viscously flow, and we're trying to prove that this gel, viscously flowing, will dissipate more energy than the compression of that foam. So I'm going to hand it over to Christina Amato, who will discuss the manufacturing process of our product. Thank you.
Hello, my name is Christina Amato, and I am the manufacturing engineer at IDP Technologies. First, I'm going to give you an overview of our product from conception to now. Initially, we were going to be creating a firefighter's helmet that had multiple subsystems, including our impact distribution padding system. However, we then decided to focus just on one subsystem, and then we also decided to move from firefighter helmets to sports helmets because there is a large increase in concussions over the past 10 years, and this problem clearly still needs to be solved. Now, in order to make our IDP technology a reality, we had to brainstorm quite a few ideas. Frequently, a gel-like material came up in our discussions to create a flow to better distribute impact. We also wanted to include the conventional foam in some manner in our new padding. Our brainstorming ideas came up with 3 viable plans. One was a glow stick-like device, where the inner pocket would be full of gel and the outer would be air, and it would work similar to a glow stick. The next idea was a waffle grid pattern, alternating squares of gel and air, and that would give space for the gel to flow into. Our final idea was just a rectangular packet with multiple pockets of gel. Now, the idea that eventually came to be was the multiple gel pockets, only we switched to one pocket of gel that's encased in a polyethylene film. We also chose a thicker polyethylene film on the outside and vacuumed out all the air. This creates free space for the gel to flow into and better distribute impact. Now, while our end user would be a consumer, we are marketing our paddings to helmet manufacturers and sell them to include in their helmets when they sell them to the consumers. This means that with 5 pads per helmet, and each pad's $1.50 each, the total cost for our padding system would be $7.50, and this would bump the price of lower-end helmets to the range of $30 to $40. And according to our results, which will be discussed later, this $40 helmet would be quite the investment.
Oh, hello there. My name is Montgomery, and I'm head R&D here at IDP Technologies. I'm going to be telling you about our prototype here today. So, the idea behind our prototype is we want to take whatever impact is not fully distributed by the helmet shell, and we want this padding, these gel packets, to take the remaining force. So we want to minimize the force. And the way we're going to do that is by having two pockets. You have an inner pocket that's filled with safe hydrogel, and then we have an outer pocket. The outer pocket encompasses the inner pocket, and it's vacuum sealed. The idea is that under critical loads of impact, the gel's going to rupture in the inner packet, and then it's going to flow viscously into the outer pocket. Originally, we wanted to have two layers of foam encompassing the helmet shell. The outer layer of the foam purpose was to buffer between the helmet shell and the gel layer so that the gel layer didn't prematurely rupture. But due to size constraints, we decided to not pursue this design. We decided to only include foam if sizing was not an issue. So for someone with a smaller head, we'd include the foam so you'd have a better fit.
My name is Dalton LaBoskey, and I'm the head for testing our product. So we started by doing 2 engineering tests and 1 evaluation test. So the first test is a seal strength test. We follow the ASTM F88 standard, which uses 2 3-inch pieces of plastic sealed together and pulled in tension on an instrument machine. Our variable was time with our sealer. We had 1 through 8 seconds that we could set the sealing time to, and we had to put those 2 pieces together, seal it, and then put it in the instrument machine. The 4 seconds proved to be the best seal time. Our second test that we performed was a compression test. So we filled the inner bag with gel, sealed it, and then sealed the outer bag around that. We put it in the instrument machine in compression between 2 steel plates, which would help us determine if the inner bag could withstand the small forces that would be seen in everyday use, and how the bag would fail. Our third test that we did was the CPSC drop test. This test is used to evaluate how effective our helmet is at distributing impact. With the help of Dynamic Research Inc., we were able to perform this test on 4 different sides of the helmet using 2 different anvils and 2 different heights. The 2 different heights are used to adjust for the type of the anvil and the impact area that will occur on the helmet. On the drop test, the helmet had to perform under 300 Gs for all 4 impacts. The overall results for the overall flat anvil for conventional helmets was 254 Gs versus 210 Gs with our padding installed. Using a hemispherical anvil, the average for the conventional helmet was 116 Gs versus 99 Gs received with our helmet.
Thank you for watching our informative video about the brand new product from IDP Technologies. And now we would like to share what we as a company have learned during this past year. What I've learned is that the design process is never really done. You will keep redesigning all the way up to the creation of the prototype. And now Dalton will tell you what he has learned.
I've learned how to research ASTM standards and how to utilize them in the engineering and evaluation of products. Brian?
I have learned that the research and development process is an arduous but rewarding one. Walter?
And I have learned that a project of this magnitude is never an easy one, but as long as your team works well together, then there will be good results in the end. So yeah, thank you for watching our video, and I hope you enjoyed it.
And break!
I know.